All right, so this is going to be the last section. So we'll do the notes today. Tomorrow will be a work day. Thursday we're going to do a review, and then that puts us at a test next Monday. Okay, so make sure you're feeling good about everything. If you have questions on Thursday, we'll go over the review. I'll give you a note card so you guys can prepare for all of that. Okay, so today's section, we've learned all about how to find all the x-intercepts. We've learned about how to find our vertex, different stuff like that. Well, today it's kind of just combining like linear and quadratics and talking about both of them at the same time. So the first question, it says, how many different ways can I have real solutions? Okay, so solutions are going to be where the two lines are going to cross, where the parabola and straight line cross. So how many different ways could I figure that out? If we were to draw a picture, so I could draw myself a parabola, correct? So here on my graph, I have a parabola. Could I draw a straight line down here and the lines are never going to cross? Is that okay? Like these are two legal lines, right? I have a parabola and then I have a linear line. So I could have it where they're never going to cross, right? Could I have something like, if I draw a line like this, how many times would this cross? Caden, how many fingers do you have back there?
2.
Yeah, 2. Okay, so I could cross no times. I could cross 2 times. Could I cross once? How would I do that, Jade?
You go straight down the center of it.
Yeah, just straight down the center of it. Yeah, I could go like this, just one spot right here. Yeah, exactly. Okay, could I cross it 3 times? I don't think I could. So I could either cross no times, 1 time, or 2 times. Okay, so that's kind of what we're talking about today. Just how many times straight lines and quadratics are going to intersect. Okay, so in our calculators, we want to figure out how many real solutions, so how many times our lines are going to cross. When I type in x squared in my y equals, and then in my other y equals, so we'll put 1 in y1 and 1 in y2. One we'll put x squared and one we're going to put 2x. Okay, so if you graph those and look at that, and then what does our graph look like? What are we going to be looking at? So is everyone seeing their quadratic with their vertex at 0, 0? Okay. And then if I were to plot some points, we have a point at 1, 1, and one at negative 1, 1. If we remember how to plot these all the way back from the first section. I would also have a point at, so I went over 1, up 1. So I can go over 2 and then up 4. Because remember, however many you go over, you square that number, and that's how many you go up, because it's x squared, so you square your x to get your y. So we have a point at 2, 4, and then one at negative 2, 4. Okay, so we have a quadratic like this. Okay, and then the line 2x, where's that y-intercept at? Brayden, what do you think?
0.
0. And then how do I plot what's its slope?
2.
2. So how many you rise over 1, what do I do?
Go 2 up and 1 across.
Yeah, up 2 over 1. And then up 2 over 1, same point, right? So here's my straight line. Not the straightest, but, and then my quadratic. So where are my solutions going to be? What are the 2 coordinates where I'm going to cross? Mackenzie, what do you think? Okay. Yeah, 0, 0, and 2, 4. Yep, Yep, so this graph, I have two solutions, it crosses twice, okay? So, just by using my slope and plotting some points. Alright, what about if we use these same equations, and this time, let's go ahead and change our line, the 2x. Go ahead and put -1 in there. So go back to your y equals and type in, we're still using x squared, but this time use 2x minus 1. And then we'll graph this one. So we have the same quadratic, so I have points at 1, 1 and -1, 1, and at 2, 4, and -2, 4. Okay, so then looking at this graph right here, how many times does it look like this one's gonna cross? Does it look like it crosses it all?
Once.
Once? Kind of looks like it just touches, doesn't it? Okay, so then Ocean, so 2x minus 1, where does that y intersect?
It's gonna be at, well, it's gonna be,
So if I'm just gonna graph 2x minus 1, where would that y intercept be?
2/1, so it'll be at 1, 2.
Okay, so, yeah, so that would be my slope, so I'm gonna start with my y-intercept down here at -1.
Yeah.
And then my slope, so I go up 2 over 1. Yep, so that hits this point right here. So yeah, so looking on your calculator, you guys can see that it just touches at 1, 1. That would be that point. So this time, the solution point would just be at 1, 1. Okay, so what about if we change our 2x minus 1 to 2x minus 8? Go ahead and switch that and see what happens. And then Haysbury, what are you looking at? It doesn't touch. Yep, because this one gets shifted down so many, it's all the way down here. It's gonna be like a line like this that's never gonna touch it. Okay? So, does this one have a solution? No. Okay? So yeah, so you can either have 2 points where they can intersect, 1 point, or 0 points. Okay? So let's go ahead, without doing this graphically, we can also solve for them algebraically. So we can solve for our solution points where they're gonna intersect each other just by substituting one equation into the other and solving for our x's and our y's. Okay, so. All right, so one equation that I have is y equals 3x squared, and then plus 3x minus 5. And the other one is 2x minus y is equal to 3. Okay, so we need to just be able to get x all by itself. So we can either solve them so that they're both equal to y, and then set them equal to each other and solve for x, or I could just take this one because it's set equal to y and just take this equation and plug it in for my y right here. Either way, we're just trying to get x all by itself and solve for x. So then, Mia, what do you want to do? Should we take this one and put it in for y, or do you want to get them both set equal to y and set them equal to each other? Doesn't matter. Okay, make them both set equal to y. Okay, so then if I need to get this one set equal to y, how would I do that? Okay. I can add my y over here, so I have 2x equals 3 plus y. And then what would I do?
You would subtract 3.
Yeah. Okay, so I have y equals 2x minus 3. Okay, so now that they're both set equal to y, I can just set these two equations equal to each other. So I'd have 3x squared plus 3x minus 5 is equal to 2x minus 3. Okay, so in order to solve for y, we've learned 3 different ways that we can do this. We can factor, we can complete the square, or we can quadratic formula. Those are the different ways we can get, or to solve for x, if we have an x squared. Okay, so what method do you guys want to use? Jade, what do you want to use? Quadratic formula, factoring, or completing the square? Doesn't matter, your pick. What'd you say?
I don't know.
Just pick one.
Formula, I guess.
Formula, you guess? Okay, so if we're going to use the formula, what do I need to do first? Yep, exactly. Yep. So that means if we choose factoring or if we choose quadratic formula, we need it set equal to 0. If we had chose completing the square, we would have needed the number on the other side. So that's why I asked you what you wanted to pick. So if we're doing quadratic formula and I need it set equal to 0, Faith, what would I do? Okay. Okay. So what would I have?
3x squared plus x minus 2.
Yeah. So I end up with 3x squared plus x minus 2 equals 0. Okay, so then from here, if we're going to do the quadratic formula, let's identify our a, our b, and our c. So if I do that, Cooper, what would those be?
3, 1, -2.
Okay, 3, 1, and -2. All right, so then we can go ahead and get these put into our formula. So if you remember, the formula is x equals -b plus or minus square root of b squared minus 4ac all over 2a. Okay, so then if we plug these numbers in, Haley Winter, go ahead and help me with that.
X equals -1 plus or minus square root 1 squared minus 4 times 3 times -2 divided by 2 times 3.
Cool. Yep. Okay, so now we can go ahead and just start solving this. So Haley Winter, go ahead and keep going.
1.
Okay.
Sorry, 1 second.
No, you're good. So the 1 squared was 1.
Plus 24
Okay.
divided by 6.
Okay.
1. Yeah, -1 plus 5 over 6.
Yeah, because we'd have the square root of 25, which we know that that's going to be 5. So we have -1 plus 5 over 6. And we also have -1 minus 5 over 6. So then what do those give me for numbers?
4 over 6, or wait, yeah, 4 over 6,
Okay.
and 1.
Yeah.
-1.
Yeah. -6 over 6, which would be -1. Yeah, so we have 4/6 or 2/3. And then we also have -1. Okay? So the two places that these two lines are going to intersect each other, so I have a quadratic, and then I also have a straight line of 2x minus 3. If I were to graph those graphically, I know that they're going to intersect twice. One time when our x is at 2/3, and one time when our x is at -1. Okay, but I'm not quite done because my solutions need x, y coordinates, and these are just my x's. So in order to figure out my y's, all I need to do is I need to plug those numbers back into one of my equations. It doesn't matter which one, you just plug them back in. Okay, so which one do you want to put them in? Do you want to put them in the linear one or the quadratic? The linear, seems easier to me. So if we plug them in, the 2x minus y equals 3. So I'm going to go ahead and plug in 2/3 because I have x equals 2/3, and then I'm also going to go ahead and plug in -1. Okay, so if I plug in 2/3, I'd have 2 times 2/3 minus y equals 3. So we need to go ahead and just solve this for y. So Megan, how would I do that?
You would do, 2 times 2/3,
Okay. Which gives me,
1 1/3.
yeah. So we have 4/3 or 1 1/3.
And then, you would add the y to the other side.
Okay. So I have 4/3 is equal to y plus 3.
And then subtract the 3.
Okay, so what does that give me? So if this was 1 1/3. Somebody help her out, who has their calculator out. So 4/3 minus 3 gives me 5/3. Negative?
Yes.
Yeah, yep, negative 5/3. Yep, negative 5/3 or negative 1 2/3, either way. They're the same. Okay, so we end up finding out that one of our solutions is gonna be at 2/3 and then at negative 5/3. That would be the coordinate where those two lines are going to intersect. Okay, so we can do that algebraically, or we just did it graphically before. So if we wanted to graph these, we could figure that out just by plotting points. Okay, so then the last one I need to figure out if I plug negative 1 in. So if I put negative 1 into my equation, so I have 2 times negative 1 minus y equals 3. So then, Kaden, go ahead and help me with this one.
So you have negative 2
Okay,
minus y equals 3.
okay,
You can add the 2, you get negative y equals 5.
Okay.
Divide by negative 1, you get y equals negative 5.
yeah, y equals negative 5. Yep, so I end up with a solution at negative 1, negative 5. Okay, so those are going to be my solutions. So algebraically, you just have to substitute one equation into the other, or just get them both set equal to y. And then because you have the x squared, we have to solve for x by using one of the methods, the quadratic formula, the factoring, or the completing the square, and get x, and then plug them back in to get y. Okay, so let's do a word problem with this stuff. So we have, it says, Andrew kicks a ball up a hill for his dog to chase. The hill is modeled by a line through the origin, so, and it has this equation, it's y equals 0.5x. So that's the slope of our hill, so. And then the path of the ball, so he's gonna throw the ball up and it's gonna come down, and the ball is gonna be modeled by negative 0.5x squared plus 6x, okay? So those are our two equations that we're working with. So we want to figure out how far the ball travels horizontally. So we want to figure out, so horizontal's this way. So we want to figure out from the guy to where the ball's going to land, like how far away that is, like how far the ball lands from the guy. And then we want to figure out how far up the hill the dog has to run to catch it. Okay, so how far the dog's running. Okay, so in order to do something like this, what I need to do is I have those two equations. This point right here on my graph, this is the point that's kind of helping me with everything. This is going to be how far the dog has to run. He has to run to that point. That would be where the ball lands on the hill. So that would be the point where I would figure out how far it travels horizontally. So if I can figure out where these intersect, that's going to help me answer all my questions. Okay, so I need to figure out the solution point, or where they intersect. So how would I do that with those two equations? Mackenzie, what do you think? What are your thoughts? So if I have two equations, what should I start with in order to figure out a solution? Could I set them equal to each other so I could solve for x? Yeah, because they're both set equal to y right now, so I could set them both just equal to each other so that we could solve for x. So if I do that, Mackenzie, what would I have? find the intersection of two graphs or of two equations, we can just set them equal to each other and then solve for x, and that's going to be the point where they intersect. Okay, so if I need to solve for x, let's pick a method. What do I want to do? Factor, complete the square, or quadratic formula? Braden, your pick.
Quadratic.
Quadratic formula? Okay, so then what should I do with this?
Minus the 5x over to the other side.
Okay, so if I minus my 0.5x over to the other side, what would I have?
Negative 0.5x squared minus 0.5x, or, yeah, minus 0.5x. No.
So if I have
Plus
6x.
5.5x.
Yep. Yep, equals 0. Yep, so since we chose quadratic formula, I can go ahead and get it set equal to 0. So then I have negative 0.5x squared plus 5.5x is equal to 0. Okay, so this is a weird one because it's like decimals, but it's still the same. We still can just use the formula. So if I identify my A, B, and C, Braden, what would those be?
0.5
Positive or negative?
positive,
For my A?
negative.
Don't we have negative? Because that was my original equation.
5.5
Okay, 5.5.
and 0.
And 0. Yep, so if you're ever missing one, you always just plug 0 in. So because I don't have a C value, I know it's going to be 0. Okay, so then we can go ahead and come over here and plug them into our formula. So if I'm going to plug these in, Ocean, go ahead and help me.
Alright, so 5.5,
Okay,
negative 5.5.
negative 5.5, yep.
And then 5.5 minus 4 is minus 4, and then negative 0.5 and 5.5. No, 0, my bad.
Okay, so yeah, so negative 0.5 times 0, and then all of it will be over
2 minus 0.5.
Yeah, 2 times the negative 0.5. Yep, so we have negative 5.5 plus or minus, and then the 5.5 squared minus 4 times the negative 0.5 times 0, and all of that's going to be 2 over 2 times negative 0.5. Okay, so then if we go ahead and solve these, Cooper, go ahead and help me out.
Negative 5.5
Okay,
plus or minus square root of 30.25.
30.25 is what that is? Okay,
And then over negative 1.
yeah. Okay. So then if I square root my 30.25,
It just says error.
it says error. What'd you type in? Whoops. So we're just square root 30.25. Let's just see what that is. Cool. Okay, so square root of that's gonna be 5.5. So I have negative 5.5 plus 5.5. All of that is over negative 1. And then I also have negative 5.5 minus 5.5, and all of that is over negative 1. Okay, so if I take negative 5.5 plus 5.5, Cooper, what does that give me? So for this first one, so negative 5.5 and positive 5.5 would be?
0.
Yep, so and 0 over negative 1 is going to be?
0.
Yep, 0. Okay, and then negative 5.5 minus 5.5, what would that one be?
11.
Okay.
Negative 11.
Yep, negative 11 divided by negative 1, which is going to give me
1. Negative 1.
positive 11, right?
Oh, yeah.
Because we had negative 11 divided by negative 1, so positive 11. Okay? Okay, so which this makes sense because if you look at what we're looking at up here, we have one, like where they intersect at 0. The two lines are going to intersect at 0. And then looking at this right here, this looks like, I mean, this is 10, this is 15, this would be 12 and a half. So this looks like it's at 11. So graphically that makes sense. And algebraically, that's what it worked out to be. Okay, so in order to answer the first question, it says, how far does the ball travel horizontally? So when I throw my ball up and it comes back down, so it comes down, isn't it gonna hit the hill like 11 feet or meters or whatever we're counting by? Yeah, feet from me. So to answer the first question, the ball is gonna travel 11 feet. Okay, is everyone okay with how I found that? Yeah. Okay, so then the other question, it says, how far must the dog run up the hill? So if I have the hill, okay, so I have like this picture right here. So I know that from me, so here I am, and then here's where the ball lands, okay? So this is the ball up here, okay? So here the dog has to run up the hill. I'm not gonna draw a dog, I can't draw dogs, okay? But I know that this distance from me to the ball is 11 feet, right? That's horizontally, my horizontal distance. From me to where that ball is gonna land is 11 feet, okay? But I need to figure out how far the dog's gonna run up the hill, so I need to figure out what this side is. So, could I go ahead and figure out this side first, figure out what my y is? Because I know what my x coordinate is, so if I were just to plug that back into one of my original equations, I could figure out my y coordinate, which would be that distance right there. And then if we think all the way back to geometry, we could use the Pythagorean theorem. Does that sound familiar at all? Kinda. Geometry was a long time ago, I know that, but. Okay, so let's go ahead, let's find our y coordinate to find this side length. So if I have the x coordinate of 11, I can plug that back into either equation to find my y coordinate. So, Jade, do you want to put it in my quadratic or in my linear one? Linear. Okay, so then we have y equals 0.5x. So if I plug 11 in that, 0.5 times 11, Jade, what does that give me? 5.5. Okay, so this is going to be 5.5 feet. So basically the solution, where these two lines crossed, my solution point was at 11 and then 5.5. That's my solution. That's going to be where the two lines meet each other. They cross at 11 and then 5.5, which is exactly graphically what it looks like. Okay, so now if we know that in our x direction we went 11, in our y direction we went 5.5, to figure out how far this dog has to run up the hill, does anyone remember what the Pythagorean theorem is? Breen, what is it?
A squared plus b squared equals c squared.
Yeah, a squared plus b squared equals c squared. Okay, and the c, if you guys remember, always stands for your hypotenuse. Okay, so that's like on your triangle, the diagonal one, okay? So the a and the b are just gonna be our legs, so either side of the triangle. So I can go ahead and just plug these numbers in, and then I'll end up solving for this side. So if I plug these in, I'd have 11 squared plus 5.5 squared is equal to c squared. So then Jade, help me solve this.
So your 11 squared would be 121.
Okay,
Then your 5.5 is 30.25.
okay,
Then you can add them two together. to
Okay.
get 151.25.
okay.
Then you can square root that to 12.3.
12.3.
Yeah, I just rounded it up.
Cool. Yeah, so we end up finding out that this side is gonna be 12.3. So then to answer the question, my dog is gonna have to run up the hill 12.3 feet in order to catch that ball. Okay, so you can see how you can use the solution points in word problems to help you figure different stuff out. Okay, questions on that? No. Okay, so then the last thing, guys, is inequalities. So we can go ahead and figure out if we're graphing. So if we have a quadratic line and a linear line, we're trying to use inequalities, so either less than or greater than or less than or equal to or greater than or equal to. So when we're trying to graph these, so first thing it says you need to solve the system of inequalities by graphing. So we're gonna graph each line separately. Then we need to figure out where to shade and then determine if your line should be dashed or solid. Okay, so if the inequality has a less than or equal to or a greater than or equal to, we use a solid line, okay, because we include those points on that line. If it's just less than or greater than, we're gonna use a dotted line when we graph it, okay? And then in order to figure out where to shade, we just have to test a solution point, which is basically just plug in a coordinate for your X and Y, and if it comes out that it's true, you shade in that area, and if it's not true, you shade in like opposite of that area. Okay, so we have these equations and we're just gonna have to graph these by hand. Okay, so we have y is less than negative 2x squared plus 12x minus 10. And then our other one, we have 4x plus y is greater than 4. Okay, so let's go ahead, let's start by graphing our linear line. The way that this linear line is written right now, do I know how to graph that? Or what do I need to do with it? Cooper, what do you think? Can I get it so y is by itself? So what would I do? Subtract the y. Okay, so I have 4x is greater than 4 minus y. Okay. So I have 4x minus 4 is greater than negative y. Okay. Okay, so then the only thing, you guys, when you end up dividing, like if your y is negative and you need to divide, you need to flip your sign. Okay, so we actually are gonna have negative 4x plus 4 is, if we flip our sign, we're gonna have is less than y. Okay, which if up here, if what we had started with, if we would have had 4x plus y is greater than 4, if we would have just subtracted the 4x, we'd have y is greater than negative 4x plus 4, which is the same thing. Y is greater than negative 4x plus 4. Okay, so depending on how you solve it out, if you end up having to divide by -1 or like changing the sign on your y, you need to flip your sign. Okay, so this is actually what we're graphing. So we're graphing negative 4x plus 4. So looking at that, Faith, where's my y-intercept going to be? At my 4, yep. Okay, so I have a y-intercept at 4, and then what's my slope for it? Yeah, because it's negative, so I'm going down 4 over 1, okay? And then down 4 over 1. Okay, so I have these points. I have a point at 0, 4, 1 at 1, 0, and 1 at 2, negative 4. Okay, so this would be my straight line. But before I go ahead and just draw my line, if I look, this is just greater than. So should I draw it with a straight, like a solid line or a dashed line? Dashed. Yep, so I'm gonna go ahead and I got this line right here, okay? So that's my linear line. Now I need to graph my quadratic. So I have negative 2x squared plus 12x minus 10. So if we think back to quite a few sections ago, I need to go ahead and find my vertex because I need to figure out where that point is to plot it. So what's one way I can find my vertex? Does anyone remember? There's either a little equation that's like h equals something, or we could complete the square. Yeah, h equals negative b over 2a. Negative b over 2a. Yep, so we can do it that way to find our x coordinate of our vertex. or we could complete the square to vertex form, either way, so we know multiple ways. So if we use it this way, my negative b, what number would that be? Yeah, positive or negative, Jade?
Negative.
Yep, so we have negative 12. And then over to, what's my a value, Jade?
-2.
Okay, so if I have 12 over negative 2 times negative 2, what would that give me?
-4.
Yeah, 12 over negative 4, which is going to give me,
3.
yeah, positive 3. Okay, so I have a vertex coordinate. The x part is at 3. Haley Winter, how do I find the y part?
Plug that in for your x.
Yeah, plug back in for my x. Okay, so I can plug that back into my original equation. So if I put, so I'd have negative 2 times 3 squared plus 12 times 3 minus 10. Okay, so then Haley Winter, go ahead and help me solve this.
Negatives, no. 36, right?
For the 12 times 3.
Oh, 36.
Yeah, that's 36, yep. And then, so 3 squared is,
9.
okay, times negative 2 would give me.
-18.
Yep, so I have negative 18 plus 36 minus 10. And then if I combine all of that, what would I have?
Eight.
8? Yeah. Okay, so my vertex is at 3, 8. Okay? So we'll go ahead, I'll draw this at the beginning of class tomorrow. I'll have this up and we'll just finish off this problem tomorrow because the bell's gonna ring in a minute. I know this one's a little bit long because I'm trying to review for your test all these different things that we haven't seen in a while, okay? So like vertex form, all that different stuff, okay?